Does the inside of a black hole lead to another universe? Attempting to escape a black hole appears more impossible than anything else. In fact, they are created when space-time collapses in on itself as a result of enough mass being compressed within a tiny enough space. Many secrets of space and time can be found inside black holes. So what lies then within a black hole? And what would happen if a black hole appeared right here on Earth? Let's find out. A black hole is a one-way exit from our universe, or is it? Black holes were first conceptualized in the 1700s as objects so huge that nothing could evade their gravitational pull. Yet Einstein's groundbreaking theory of gravity, which was finished in 1917, is where the contemporary tale of black holes really begins. Throughout the past century, scientists have created models of what black holes must look like using Einstein's theory of gravity. In theory, any object, even a rock, can be converted into a black hole by being compressed into a small enough space. In these circumstances, the object keeps falling to zero size as a result of its own weight. According to Einstein's theory, the object's mass and gravity do not disappear, but rather manifest themselves as a severe deformation of the space and time it is in. The black hole is this bending of space and time. Large stars, stars that are several times more massive than the Sun, are the only things in nature that have the capacity to spontaneously generate a black hole. These stars eventually die and fall to the ground, creating a black hole as a result. The resulting black hole is only a few miles across, despite the fact that the initial star may have been millions of miles wide. The hole itself is spherical, like a beach ball. The resulting black hole is the deepest black in the cosmos, since no light, no matter how strong, can ever bounce back from it because all light is absorbed by the hole. Any object that crosses the horizon of a black hole, which is a genuine hole in space, is swallowed up indefinitely. Because of this, black holes are regarded as the edge of space and a one-way door out of our world. Nothing within a black hole can ever, even in theory, connect with our universe again. Black holes, though, are stranger than that. In contrast to time far from a black hole, time moves more slowly as you approach closer to one. Any large body, such as the Earth, causes this effect according to Einstein's hypotheses. Because of how weak Earth's gravity is, the effect of time slowing has been observed and verified by sensitive instruments. For instance, if you lived on top of Mount Everest, you would age 1/1000th of a second faster than you do at sea level. The tremendous slowing of time is found close to a black hole. Time is stopped from the perspective of an observer outside the black hole. The border of the hole, for instance, would seem to be frozen in time as an object fell into it. The inside of a black hole is an actual mystery. According to Einstein's theory, inside the hole, time and space sort of swap places. The passage of time itself inside the black hole pulls falling items into its core. Neither we nor any force in the cosmos can stop this fall or the passage of time. Our knowledge falters right at the center of the black hole. According to Einstein's theory of gravity, time appears to be destroyed at the hole's center and abruptly ends there. Because of this, a black hole is occasionally referred to as the reverse of creation. Yet no one is aware of how or why time can stop suddenly, just as nobody is aware of how time was initially formed. At the smallest stages of separation, Einstein's theory of gravity is no longer valid, and new natural laws must be discovered to explain what occurs within a black hole. Does the interior of a black hole, as some scientists have suggested, connect to another universe? In actuality, nobody is truly aware. Even in theory, we are unable to conduct a direct experiment to answer this question because no data or proof can ever emerge from a black hole. That is why it's crucial to detect black holes and study them from the outside, while also creating theories that can more accurately anticipate what might occur inside the black hole. What takes place within a black hole? The solution to this question can only be found by creating a more accurate fundamental theory of space, time, and matter. Unfortunately, Einstein's theory of gravity, which is what first inspired the concept of black holes, does not provide a reliable forecast of what would occur at the tiniest scales of space. For instance, even though all the atoms in our body contain electrons, these tiny dense particles should generate black holes. They obviously don't. Why not? There may be more dimensions of space than the 3 we can perceive if emerging theories of physics like string theory are accurate. These extra dimensions may be crucial in explaining how matter behaves at extremely short scales of distance, including what occurs at the center of a black hole. The greatest benefit of black holes may be their contribution to our understanding of the fundamental principles at play in the universe. Scientists have managed to get a glimpse inside black holes in the interim. A new model that was developed using gravitational waves that were discovered for the first time over 10 years ago shows what is happening inside those enigmatic objects. The new research may someday enable us to comprehend what occurs when they merge, which is arguably the most dramatic and extreme occurrence ever recorded in the universe. 2015 saw the first gravitational wave discovery. Black hole collisions cause disruption that reverberates throughout the cosmos, and scientists have deployed sophisticated and accurate technology to observe these disruptions in space-time. Scientists have subsequently discovered nearly 100 merging black holes as a result of gravitational waves that have since diffused throughout the universe. Scientists compare the procedure to shaking a box and attempting to determine the nature of the contents by listening to the sound that is released. 2 black holes colliding in this instance caused the shaking, and the examination of the gravitational waves they produced the sound. These measurements were used in new research to improve models of the cosmic events. This should make it possible for researchers to map the internal dynamics and examine the applicability of Einstein's general theory of relativity to extremely hostile conditions. Up until now, scientific models have relied on interactions that are linear. The new research on nonlinear interactions could enhance models by up to 10%, but they are still limited because they don't take into account other types of behavior. Further observations will benefit as well as the discovery of other black hole collisions. Because of the pandemic, LIGO, the observatory that first discovered those gravitational waves, has been inactive since 2020. But in the upcoming years, new systems will be activated that might be able to locate black holes more. What would happen if there were a lot of black holes swarming the universe? Fortunately, black holes are not entirely black. Some radiation and particles can escape through the intricate quantum mechanical process known as Hawking radiation, which occurs at the black hole event horizon. They lose mass more quickly as they get smaller. Black holes that weigh less than about 100 million tons, or about the same as an average asteroid, will lose about half of their mass in the course of the universe's history. Black holes that are larger than that will only lose a small portion of their mass due to the nature of Hawking radiation. Depending on how much of the dark matter you want to explain to them and how big each one is, you can estimate the total number of little black holes in each galaxy. But either way you cut it, there are a lot, and they are all quick. According to computer calculations and studies of the dynamics of galaxies, dark matter travels at a speed of more than 100 miles per second. A black hole the size of an asteroid might travel from Jupiter to Earth in a matter of weeks if it were moving at that rate. What would occur if a black hole the size of an asteroid collided with Earth? Disaster, in a word. The black hole would rip through the surface of our planet like a hot knife through butter, but due to the gravitational pull of the Earth, it would immediately start to slow down. Any atom, molecule, or person that crosses the event horizon, the point at which nothing, not even light, can escape from a black hole, would instantly vanish from the visible world and never be seen again. The black hole's best-case scenario would be for it to leave through the opposite side of the Earth, leaving the survivors to tidy up the debris. In the worst case, the black hole would crash into the center of our world, where its gravitational pull would be strong enough to enable it to start consuming matter. It would eventually eat up the entire world. Fortunately, scientists' estimates indicate that there is very little probability of a black hole entering the core of Earth. Black holes move too quickly. On the other side, our planet would heat up if it came into contact with a black hole, which is another terrible outcome. The black hole would accrete matter as it passed Earth, and this accretion would produce heat, the same heat that powers active galactic nuclei. The energy released by the collision of an asteroid-mass black hole would be comparable to that of a kilometer-wide asteroid, a dinosaur killer if you will. Fortunately, black hole collisions are probably uncommon. Calculations suggest that there may be one collision or so every billion years under the most optimistic scenario. Optimistic by the scientist standards, that is, populating the galaxy with the maximum amount of black holes. Is there a way for us to be saved? By merely existing and having life continue to flourish on our planet for almost its entire existence, it seems obvious that humans have won the cosmic lottery in many ways. If we found out we were about to lose the ultimate cosmic lottery and that a black hole was heading right for us, what would happen? Despite the slim chances, it is astronomically plausible, and given that the Milky Way contains 400 billion stars, a 1 in 400 million possibility indicates that a black hole has likely gotten around 1,000 stellar systems over the time that our planet has existed. Regressively guessing out of the way like ludicrous was the only choice left at that time. To escape the black hole, you would need to move the entire solar system, which is unavoidably only possible through gravitational interactions with other massive bodies. Since the Earth cannot be moved on its own, this would require moving the entire solar system. In other words, the same occurrence we're trying to avoid, significant gravitationally perturbing the orbits of the planets in our solar system, is the only thing that could save us from being swallowed by an approaching black hole. After uninterrupted billions of years of continuous existence on our planet, if this scenario came to pass, the only sane course of action would be either to depart spaceship Earth or otherwise accept that we would perish along with it. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.